Hello everyone, welcome to Vega Plus Academy YouTube channel. So today in this video we are going to discuss universal law of gravitation, which is also known as Newton's universal law of gravitation. So this is also known as Newton's universal law of gravitation. Why it is known as Newton's universal law of gravitation? Because it was proposed by Newton. Okay, now without any further delay, let's get started. First of all, we will go through the statement of the universal law of gravitation. Okay, we'll go through the statement. Starting with the statement says that every object in the universe attract every other object with a force which is proportional to the product of their masses. Here the point should be noted that the force is directly proportional to the product of their masses. Okay, you can see here force is directly proportional to the product of their masses and inversely proportional to the square of distance between them, and that the force which is acting between the two objects is also inversely proportional to the square of distance between them. And we will understand this statement with the help of examples. Suppose we have examples of two objects, namely object 1 and object 2, with the center C1 and the object 2 center is C2, and the distance between them from the center to center distance is capital D. Suppose we have a object 1 mass is capital M, that is, suppose this is our M1 mass, which is capital M, and this is our M2 mass, which is our small m. This all thing you have to write in the derivation. It is somehow derivation you are doing. Okay, you have to write, let the object 1 mass be capital M and object 2 mass be small m, and the distance between them from center be D. Okay, you have to write this. Now the force says that force is proportional to the product of their masses, that is, the force which is acting on the object 2 by the object 1. This force which is acting on object 2 by the object 1 is directly proportional to the product of their masses. Somehow this will also exert the same force on object 2, but they are equal and opposite in nature, and both are attractive force. This object will attract the object 2 with a force which is proportional to their masses and inversely proportional to distance between them. Same will be applicable for the object 2. Object 2 will attract object 1. Okay, so I am saying that the force are equal but opposite in direction, and both are attractive force, because here gravitational force are attractive in nature. You should know that gravitational force are attractive in nature. Okay, so from the statement we will get that force is directly proportional to the product of their masses. This is our M1 and this is our M2. So the product of their masses would become M into this is small m. Okay, so this is our equation 1. Mark it as equation 1. Force is directly proportional to the product of their masses. Hope so you are understanding this concept. Now force is also proportional to the square of distance between them, that is inversely proportional to the square of distance between them. Here distance is D, so I have done the D2 square. Okay, this is our equation 2. Mark it as equation 2. On combining this equation 1 and equation 2, on combining equation 1 and 2, we get, so friends, if you will combine this equation 1 and equation 2, you will get force is directly proportional to M into M upon D square. You will get finally this equation. Now you have to remove this proportionality and you have to equate to with the equal to sign. Then one proportionality constant will come, that is G, and this will be M upon D square. Therefore force will become G mm upon D square. This is our final equation. Therefore the force, that is the gravitational force which we will get, is F equal to G mm upon D square. Now you have to find the unit of this G, because one thing has arrived here, this G. This G is also known as universal gravitational constant. So this is the universal gravitational constant, and its value was found out by Henry Cavendish by using the sensitive balance, and it was 6.673 into 10 raised power minus 11 Newton meter square per kg square. So this the universal gravitational constant value would be fixed everywhere. Does not think that if you will take this object 1 and object 2 the moon or in any Jupiter or other planet, then this value of G would not change. Okay, you should keep in your mind that this value of G will not change. Now after finding the relation between the force and masses and the distance between them, you have to find this that the G SI unit. You have to go for the SI unit of this G, because already the value of G was found out by Henry Cavendish. So now you have to find the SI unit of this, that is Newton meter square per kg square. This is important for the board examination. You somehow they are giving MCQs and asking the SI unit of G. So I am evaluating here the SI unit of G. You can go through it. Now for getting the value of G, you have to rearrange this equation. What you have to do? You have to rearrange this equation. That is force equal to Gm m upon d square. Now rearranging this, that is multiply the d square with the force F into d square and divide these masses upon m into small m equal to G. Now for getting the SI unit of G, you have to put the SI unit of force, distance and masses. Okay. Hope so you are understanding. For getting the SI unit of G, you have to put the SI unit of the respective quantities that are force, and here we have the another quantity which is distance. Here distance square, that point you should note in your mind. Okay. Now this will become the SI unit of force is Newton and the SI unit of distance is meter. So this will become meter square. That is masses. SI unit is kg and this will also become kg. So we will get the SI unit of G as Newton meter square per kg square. This is our final, the SI unit of G. So today friends, we have covered only the universal gravitational law, and in the upcoming video we'll cover the further topic related to this chapter. Okay, hope so you will like the video. If you like the video, please share with your friend and also subscribe the channel. Thank you.